Hello, we are students of Dwarkadas J. Sanghvi College of Engineering, final year, batch of 2022 from the Electronics Engineering Department. My name is Parth Thakkar, SAP ID 39.
Vaibhav Sanghvi, SAP ID 59.
And I'm Vedant Rai, SAP ID 61.
Firstly, we'll cover the hardware aspect of our project. We have the ESP8266 node MCU here. Then here is the environment temperature and humidity sensor DHT11 connected to D3 pin. Then is the DS18B20 soil temperature sensor connected to the D2 pin, and lastly the capacitive soil moisture sensor connected to the A0 pin to measure soil moisture percentage of the soil. We have coded the node MCU such that the onboard LED will blink until it's connected to the Wi-Fi. Upon being connected, it stops blinking.
The data from the node MCU, once connected to Wi-Fi, is sent to a cloud-based database. Our system works on a level 5 IoT implementation, so the analysis is also done on a cloud platform. We use Google Sheets as our database platform. A special feature that comes with using a Google Suite product is the ability to code the backend of it as per a user's requirement. Therefore, on the backend of Google Sheets, we have implemented the analysis aspect of our system, which is reflected on our app based on Flutter. As can be seen, our data from the node MCU is being updated on a new row corresponding to the correct date and time on Google Sheets. As this is only a database aspect, data from here in JSON format is sent to our application.
This is the mobile application which we have developed. We have developed this application using Flutter, and the IDE used is Android Studio. The buttons and the UI have been designed using a material package of Flutter. As this is the home screen of our app. At the bottom you can see we have our acknowledgements. To the right we have a video recording option. The video recording option opens a video in which you can see the group members explaining the project. To the left we have a plant repository. The plant repository currently has 4 plants, but it can be expanded as and when required. So each plant, as you can see, it has a description about itself, and then it has the ideal conditions at the bottom. So for the rows, you can see the ideal conditions are a soil moisture percentage of 41 to 60%, a temperature of 18 to 28 degrees Celsius, and a humidity of 60 to 70%. Similarly, we have data for all these other plants. Then we see the sensor data. So the sensor, on selecting sensor data, you will be given two options: live data or the graphs. The live data can be used to check the current data being relayed by the sensors, while the graphs are used to display historical trends. So when you click on live data, you can see the current data. We have used list builder to display this list. The upper readings are the newer ones, while you can scroll down and check older readings. So each reading will have the date and time at which the reading was taken. It has the soil temperature of at that particular time. It has the air temperature also, the air humidity, and the soil moisture content. Then in graphs, the graphs, as I said, can be used to check historical trends. So first, the topmost graph is the soil moisture percentage graph. As you can see, we have included an option to change the number of entries being plotted on the graph. So this will display a graph of the last 40 entries of the soil moisture. Similarly, we have graphs of the soil temperature, then we have of the air temperature, and finally of the air humidity.